To start off my presentation, I'll quickly run through my CPU and explain some of its functions. For the first task, all I have to do is save two values in the registers and then send them to the display. For the second task, I again have to print out a message, but also have to do some math. I put the values that I want into the registers, in this case 3 and 4, and send them to my ALU. If the select bits are 0, 0, and the write enable for the accumulator is on, then the sum is output. I then save the value in register 0 and set register 1 to 0, 0, 1, 1 and output the answer. The third task is accomplished in a similar manner. I am sure this is not the right solution. I stored the value I wanted multiplied in both registers and then added it to itself the number of times I wanted it multiplied. I accomplished the software subtract by making the 2's complement of the number to be subtracted and added it with the other number. I was able to get the 2's complement of 3 by XORing it with 1, 1, 1, 1, or 15, which flipped every bit, and then I added 1. To achieve the hardware subtract, I did essentially the same thing, but all at once inside my modified addition subcircuit. I did this by XORing each B input with a control input that was 0 for addition, or 1, which generated the 2's complement for subtraction. To add 1, I simply wired the control input to the carry-in input for the least significant bit. Let's take a look at my subcircuits as soon as this is finished. Here's an example of my 4-bit register, which saves my 4-bit words, which uses my 1-bit register for each bit. Here's an example of my ALU, has the control line for the addition and subtraction. Here's the accumulator, which saves the value of any of the operations, which are add and subtract, OR, and XOR. Here's my adder, which I use in my 4-bit adder, my OR, my AND, which takes 4 bits, each of these do, my XOR, my 4-bit adder, which I use the control input to achieve subtraction when this is true, and my register file, which saves my 2 4-bit words